everybody, welcome to week 11 of Chemistry and Society at Rock Valley College. We are nearing the finish line. In fact, your to-do list should be getting much shorter. Let me kind of get down to what we've got over there. Let me click on modules. Many of you did not do the lab from last week. So you remember, I accept those with 2 points per day penalty, and we also have the missing lab policy, so be careful. It's a really easy lab, just need to have some sunshine, which last week we had a lot of, but this week not so much. So make sure you pick a day if you still need to do it, and go outside and play with some sunscreen. All right, so let's close up shop on week 10. Week 11, notice our weeks and the information on the requirements are getting a lot less. So we're covering chapter 11 this week. So you've got to go to the Smart Book and do the exercise for chapter 11. For those that like the PowerPoint, they're here. And then this week's lab is the caloric content of food with the drop box here. I did want to show you something. I noticed students in my other class, in the 16-week class, they're a few weeks ahead of you. They really struggled with the main calculation for this lab. So what's going to happen, you're going to burn some food. You're going to do 3 different items, and you're going to burn food. I mean, imagine like roasting a marshmallow over a fire. You're going to light a piece of food, like maybe a marshmallow, on fire, and it's going to burn, and it's going to heat up water. And what's happening is energy is being converted and transformed and transferred from the food into the water and heating it up. So the first thing the lab has you do once you collect all your data and do some basic subtraction of temperatures and mass and things, but the first thing it wants you to do is calculate how much heat energy was absorbed by the water. And if you see on my screen right now, this is from the lab, this is the equation you're going to use. The energy absorbed by the water is equal to delta T, which is the change in temperature, so how much the water changes temperature, times mass of the water that's heated up, times C, which is a constant. We're only using water, so I'll show you what that value is in just a second. So it's a constant. So just multiply the 3 things together and you've got your energy. Now there's one other additional thing, and in fact there's an example right here. Let me get the little things showing. Q, the heat energy released by the reaction and therefore absorbed by the water. For this particular example, the delta T, the temperature change, was 10 degrees Celsius. You're going to heat up about 50 grams of water, so multiply by the mass of the water heated, times, here's that constant. The specific heat capacity of water is how much energy it takes to raise 1 gram of water 1 degree Celsius, and it happens to be 1 calorie. However, one last step here, and that is the energy absorbed by the water should be in the units of kilocalories, or kcals, as you can see here. So the one last step, if you want to do it all at once, is to convert those calories into kilocalories. So when you look at this equation, you're going to plug in your change in temperature, you're going to plug in your mass of water, and then you're going to leave these last 2 values as is. So 10 times 50 times 1 divided by 1,000. For this particular example, it was 0.5 kcals of energy absorbed by the water because it was given off by the burning combustion reaction of your food. Now the next thing it asks you to do is to figure out the energy per gram of food burned. So you take the value from this last one, 0.5 kcals, and you divide it by the mass of food that's burned. And the lab has you, what the lab has you do is weigh everything at the beginning, the food, the container, all that, and then weigh it again at the end and subtract the 2 numbers. And that's the mass of food burned. Everyone was doing that part right, but they weren't, these last 2 things they weren't really getting correct. So take the energy, 0.5 kcals in this example, divide it by your mass of food burned, and you'll get an answer in kilocalories per gram. And then finally, you're going to calculate the percent difference based on the food label. So whatever food item you need, you also have to have the little nutrition label off the back, and you're going to pull up the value for what we call it the theoretical value, which is what is it in theory? What's it supposed to be? How much energy per gram? From the nutrition label, and you're going to compare it to your experimental value. So in this example above, the experimental value is 1.3 kcals of energy per gram of food burned. And you're going to plug it in here and do your percent difference. And then here's an example up there. It shows you how to get the theoretical value from the nutrition label, and then how to actually do the work. So depending on how close or far off you are, you know, you'll see what your difference is. Hopefully your difference is 0, but there's quite a bit of error in this experiment. Energy is released because you've got your container, and yeah, the flame is burning up towards the bottom of your container of water, but it's also burning and heating up the surroundings. So it's far from a perfect experiment, but it works pretty well. As an FYI, determining the caloric content using the Atwater factors, you don't have to do that part. Okay? So just as an FYI on that. All right, that's what you got this week, Chapter 11 and Lab 13, and guess what? That's our last lab. If you have not missed any labs this term and you're really happy with your lab scores, remember I do drop 1. So if you want to make this as your drop and not do it, it counts towards your total, because I count up how many zeros total you have in the lab missed. But if you haven't missed anything and you're happy with your scores, you don't want to try and get a higher score, you're welcome to skip it, and that'll be your 0. So that's what's happening, and I will talk to you again at the beginning of next week, our last full week of classes. Take care.